Welcome to my 6th lecture on circuit theory. Today we will continue learning about the Laplace transform. Today, first let us determine the Laplace transform of an unit impulse function. That is, we want to determine this one. Delta t means what? Delta t means unit impulse function. You all know what this is. Now, in order to determine this unit impulse function, we will try to recall one very important property of the unit impulse function, that is sampling property. Now, what is the sampling property? Now, sampling property says us that the integration minus infinity to infinity ft delta t minus t0 equal to what? F t0. Okay, the function value at the instance t0. Or if we make t0 equal to 0, then minus infinity to plus infinity ft, this is dt, ft delta t dt equal to f0. Now, from the definition of Laplace transform, we know that Laplace transform of delta t or u0t equal to what? Minus infinity to infinity delta t e to the power minus st dt. Now let us compare these two integrations. Here, comparing these two integrations, we can say that ft equal to e to the power minus st. Here ft, and here we wrote e to the power minus st. So ft equal to e to the power minus st. So the value of the result of this integration will be ft0, f0 or e to the power minus st at t equal to 0. So we all know that this is equal to 1. Hence, Laplace transform of delta t or Laplace transform of u0t equal to simply 1. Okay. Now, let us determine the Laplace transform of a constant k. Laplace transform of a constant equal to 0 to infinity k e to the power minus st dt. This is what? Minus k by s e to the power minus st. The upper limit of this function is infinity and lower limit is 0. Now this is equal to minus k by s e to the power minus infinity. E to the power minus infinity, we all know that the magnitude of e to the power minus infinity equal to 0 minus e to the power 0. E to the power 0 means 1. So the result is k by s. So the Laplace transform of any constant is equal to the constant by s. So the Laplace transform of 1 gives us 1 by s, and Laplace transform of E, a constant voltage, equal to E by s. Okay, we have to remember that here the limit of the integration was 0 to infinity. So this is a causal function. This function is a causal function, or this function is non-zero on and after t equal to 0 or t greater than equal to 0. So this is the Laplace transform. This is the Laplace transform of actually E ut. this is equal to E by S. Okay. Now let us determine the Laplace transform of t to the power n ut. So from definition, Laplace transform of t to the power n equal to t to the power n e to the power minus st dt. Okay. Now let us imagine st equal to x or t equal to x by s or dt equal to dx by s. So this integration will become 0 to infinity as st equal to x. So the limit of the integration will remain unchanged. Now let us replace t by x by s and st equal to x. Here dt equal to what? Dx by s. So we will get 1 by s to the power n plus 1. This is constant with respect to x. S is constant and n is constant. So we can well take it out from the integration. So this is equal to 1 by s to the power n plus 1 integration 0 to infinity x to the power n e to the power minus x dx. And we all know that this integration represents gamma n plus 1. So the result of the integration will equal to gamma n plus 1 by s to the power n plus 1. Now gamma n plus 1 means n gamma n. N gamma n means n into n minus 1 gamma n minus 1. So if n is an integer, this will end to n factorial. So the result of this integration or the Laplace transform of t to the power n will become factorial n by s to the power n plus 1 when n is an integer. If n is not an integer, then we have to determine gamma n plus 1 separately. In this regard, these two gamma values are very important. That is gamma half equal to what? Root pi, and gamma minus half equal to minus 2 root pi. Now let us determine the Laplace transform of u minus 2t. U minus 2t equal to what? We all know that u minus 2t equal to t square by 2 ut, or this is one ramp function, unit ramp function. Sorry, u minus 2t equal to ramp function tut. So the Laplace transform of t is what? N equal to 1 here. So this is gamma n, that is gamma n plus 1, that is factorial n or factorial 1 by s to the power 2 or 1 by s square. Okay. Now let us determine the Laplace transform of u minus 3t. U minus 3t equal to one unit parabolic function, or u minus 3t equal to t square by 2 ut. So the Laplace transform of this one equal to t square half Laplace transform t square ut. So n equal to 2 here. Therefore, put n equal to 2, then we will get this is factorial 2 by s cube. So we all know that factorial 2 equal to 2. So 2 by s cube, these 2 will be cancelled out. So the Laplace transform of unit parabolic function is 1 by s cube. Now let us determine the Laplace transform of root t or root t ut. So Laplace transform of root t equal to Laplace transform of t to the power half. So from definition we will get this is gamma n plus 1. Here n is not an integer. So gamma n plus 1, that is half plus 1 by s to the power half plus 1. So gamma n plus 1 equal to, I told you that gamma n plus 1 equal to n gamma n. So half gamma half by s to the power 3 by 2. Now gamma half equal to what? Gamma half equal to root pi by gamma half equal to root pi. So the Laplace transform of root t equal to half into root pi by s to the power 3 by 2. Now lecture we have discussed about 4 very important properties of Laplace transform. Today let us discuss about a few more important properties of Laplace transform. Important properties, let us take this one first today. Property 5. Property 5 tells us that if ft and fs are Laplace transform pairs, that is Laplace transform of ft equal to fs, if ft and fs are Laplace transform pairs, then Laplace transform of t to the power n ft equal to what? Minus 1 whole to the power n. Then we have to do the nth derivative of fs with respect to s. Okay. Now in the very next property we have to discuss about this one. If ft and fs are Laplace transform pairs, then Laplace transform of ft by t, this is equal to integration s to infinity fs ds. So Laplace transform of this one ft by t to the power n equal to, we have to make some successive integration of fs with respect to s, and number of integration is n times. Let us discuss about another very important property, that is say property number 7. Property number 7 says us that if ft and fs are Laplace transform pairs, then Laplace transform of e to the power minus at ft equal to f s plus a. Okay. Now let us learn about another very important property. The property 8 says us that if this ft and fs are Laplace transform pairs, then a Laplace transform of the delayed function. This is a delayed function. If ft is a function, then this is the same ft function but with a delay a. This is equal to what? E to the power minus as fs. Okay. Discuss about one more property. So we will call this as property number 9. Property number 9 says us that if ft and fs are Laplace transform pairs, then Laplace transform of f(at) equal to what? f(at) equal to 1 by a f s by a. Okay. Now let us solve some problem about the Laplace transform. Now let us take the problem number 1. We have to determine the Laplace transform of one damped sinusoid given by sin a e to the power minus at sin omega t plus phi. We have to determine the Laplace transform of this quantity. So this is the Laplace transform of a e to the power minus at sin omega t plus phi equal to what? Sin omega t cos phi plus cos omega t sin phi. So this is equal to a, as a is constant. So let us take it out from this operation. So this is equal to a into e to the power minus at sin omega t cos phi plus e to the power minus at cos omega t sin phi. So in the Laplace transform, the t function, the function of t is transformable. So these are constants. These are two constants. So let us take these two out also, like a. So we will get this as a into cos phi into Laplace transform of e to the power minus at sin omega t plus this is sin phi into Laplace transform of e to the power minus at cos omega t. Now we know that Laplace transform of sin omega t equal to what? Omega by s square plus omega square, and Laplace transform of cos omega t equal to what? S by s square plus omega square. Okay. Now, and we also know that if ft equal to fs, then Laplace transform of e to the power minus at ft equal to f s plus a. Okay. Now s should be replaced by s plus a. Therefore, the Laplace transform of e to the power minus at sin omega t equal to what? This is we have to replace s by s plus a. So this is equal to omega by s plus a whole square plus omega square. Similarly, Laplace transform of e to the power minus at cos omega t equal to what? This is s plus a by s plus a whole square plus omega square. Okay, let us just put these values here. So the Laplace transform of a e to the power minus at sin omega t plus phi equal to what? A into cos phi e to the power minus at sin omega t equal to Laplace transform of this one equal to omega by this, and Laplace transform of this one equal to this. So this is equal to sin phi into s plus a by s plus a whole square plus omega square. Okay. Now let us take this function. Let us take this function. This is what? This is a pulse function, unit pulse function. Now it would be better if we take this function first, more generalized function. This one, ft equal to this one. This starts from t1 and the interval is from t1 to t2 and the magnitude is here 1. So this is also a gate function. So ft equal to, we can write this ft equal to u t minus t1 minus u t minus t2. We have to determine the Laplace transform of this ft, or we have to get fs corresponding to this ft. So fs equal to Laplace transform of u t minus t1 minus Laplace transform of u t minus t2. Now we all know that Laplace transform of ut equal to 1 by s, and if Laplace transform of ft equal to fs, then Laplace transform of f t minus a equal to e to the power minus as fs. This is a delayed function, the amount of delay is a. These two are also the delayed function, delayed unit step function. Therefore fs equal to fs equal to, this is 1 by s e to the power minus t1s minus, for this one the Laplace transform of unit step function is 1 by s, but this is a delayed function. So due to the delay we have to add another quantity, that is e to the power minus t2 by s. So Laplace transform of this function is equal to 1 by s e to the power minus t1 by s minus e to the power minus t2 by s. So if let us call it gt. So if one or if we know the process, then the Laplace transform of gt equal to what? Laplace transform of gt, we have to call it gs, capital Gs equal to 1 by s. Here t1 equal to 0 and t2 equal to t. t1 equal to 0 means we e to the power minus t1s equal to 1 as t1 equal to 0, and we have to put t2 equal to t. So this is equal to e to the power minus ts. Okay. Now let us take the third example. We have to determine the Laplace transform of a function, this function. This is what? This is one ramp function, but this is a bounded ramp function. The ramp interval of the ramp function is from only 0 to t. Now the amplitude is say k. So ft equal to what? Ft equal to y equal to mx, y equal to mx, or m equal to the slope of the curve, the slope of the line. Slope is what? This tan theta equal to k by t into t, but as this is the bounded function, so we have to multiply this function. This is the gate function. This is the gate function g0t, and g0t equal to 1 only when t equal to in this interval 0 to t. Okay. Otherwise this term is 0. Okay. So ft equal to k by t into t into ut minus ut minus t. So we have to determine the Laplace transform of this one. Now let us simplify this as this is equal to k by t into t ut minus k by t into t u t minus t. Now let us keep it as usual, and let us make this t as t minus t plus t, and this is as it was into ut minus t. Now let us take this one first, t minus t and t separately. So ft equal to, ft will become this minus k by t, t minus t, u t minus t plus into minus equal to minus k by t into t into u t minus t. So let us cancel out these two t. So finally this is equal to k by t into t ut minus k by t t minus t u t minus t minus k u t minus t. Therefore the Laplace transform of this ft equal to what? We all know that Laplace transform of t ut equal to 1 by s square. So Laplace transform of this one equal to k by t into 1 by s square. Now these two functions are identical except this delay. The amount of the delay is t. So we all know that if Laplace transform of ft equal to fs, then Laplace transform of ft minus a equal to e to the power minus as fs. Hence, the Laplace transform of this function is the Laplace transform of this function into e to the power minus s into t. Here the amount of delay is t. So this is equal to k by t into 1 by s square e to the power minus st. Okay. Now we all know that Laplace transform of ut or unit step function equal to what? 1 by s. This is a delayed unit step function and the amount of delay is t. So this is equal to k by t into 1 by s into e to the power minus st. Okay. Now let us learn how to determine the Laplace transform of a periodic function. A periodic function means repetition of the same function. Let us take this function, this one. This is a periodic function. Now this periodic function is the repetition of this function or this slice. Now this period, the time period of this one is t. So this is say ft, and this one is say f. This is say f1t. Therefore we can say that ft equal to f1t plus what? This function, this one is delayed version of this function and the delay amount is t. So we can write this one as f1t minus t. We can write this one as what? f1 t minus 2t and so on. Therefore ft equal to, let us say, the Laplace transform of f1t equal to f1s. Therefore Laplace transform of ft equal to the sum total of Laplace transform of all these functions. So this will be equal to f1s plus this will be equal to what? E to the power minus st, as the amount of delay is t. So this is e to the power minus st f1s plus e to the power minus 2st f1s plus so on. So this is equal to f1s into 1 plus e to the power minus st plus e to the power minus 2st plus e to the power minus 3st plus ... Therefore this is equal to this one. Okay, we can write this as 1 by 1 minus e to the power minus st. Okay, where t is the time period. Okay, this is the Laplace transform of this periodic function. Let us take one more example. We have to determine the Laplace transform of this one. This is a bounded sinusoidal function. You can recognize this as a part of the sinusoid. The amplitude of the sinusoid is A and time period of the sinusoid is t by 2. But this is a bounded sinusoid. As this is a bounded sinusoid, say this is bounded from 0 to t by 2. So we can express this as the sinusoid A sin omega t into ut minus t by 2. Okay. Now here omega equal to what? Omega equal to 2 pi by t. So this is equal to sin 2 pi by t into t ut minus t by 2. Okay. Now hence ft equal to a sin 2 pi by t into ut minus a sin 2 pi by t into ut minus t by 2. Now this is say f1t. Let us call this function as f1t and that function as f2t. Hence Laplace transform of ft equal to Laplace transform of this function minus Laplace transform of that function. Now let us take these two functions separately. f1t equal to what? A sin 2 pi by t into t ut. Therefore Laplace transform of this function or f1 is equal to a into omega by s square plus omega square. Omega equal to 2 pi by t. Whole square. Now let us take f2 separately. f2t equal to a sin 2 pi by t into t minus t by 2. Now let us write t as this one, t minus t by 2 plus t by 2 u t minus t by 2. I did this operation in the previous one example. Let us take t minus t by 2 first. So this is equal to a sin 2 pi by t minus t by 2 plus 2 pi by t into t by 2. Okay, and the whole thing is multiplied by this delayed unit step function. Now these 2 and tt will be cancelled out. So this is equal to a sin 2 pi by t minus t by 2 plus pi ut minus t by 2. We all know that sin pi plus theta equal to what? Sin pi plus theta equal to minus sin theta. So f to t will be reduced to this one, a sin 2 pi by t, t minus t by 2, u t minus t by 2. Okay. Now this f to t, the nature of f to t is same as f1t, but f to t is delayed by t, the amount t by 2. Okay. Therefore the Laplace transform of f to t equal to the Laplace transform of f1t into e to the power minus t by 2 s. So this is equal to a 2 pi by t by s square plus 2 pi by t square into e to the power minus s t by 2. Okay. The Laplace transform of f2 t equal to 1 minus will come here due to this one. Therefore Laplace transform of minus f2 t, hence the Laplace transform of ft will be equal to this one minus this one. Minus into minus will make this one as plus. So this is a into 2 pi by t by s square plus 2 pi by t whole square. The whole thing will be multiplied by 1 plus e to the power minus s t by 2. Okay. Hence we have seen that the Laplace transform of this function is this one. Now say we want to determine the Laplace transform of one rectified sine wave. One rectified sine wave. This is say gt. Now this is up to t by 2 and this will start again repeating itself after t. This is t plus t by 2, that is 3t by 2. This is 2t. Okay. So this is nothing but a repetition of this one, or this is a periodic function of this one. We all know that the periodic function, the Laplace transform of the periodic function is f1s by 1 minus e to the power minus st. If this is f1t, then the Laplace transform of this one is equal to, this is Laplace transform of gt equal to fs by 1 minus e to the power minus st, where t is the time period. Here the time period is t. Hence the Laplace transform of this one, Laplace transform of gt, or Laplace transform of one rectified sine wave of amplitude a equal to the Laplace transform of this one fs. Let us write this first. A 2 pi by t s square plus 2 pi by t square, the square of s square plus 2 pi by t square into 1 plus e to the power minus st by 2 by 1 minus e to the power minus st. Now we can express 1 minus e to the power minus st as 1 minus e to the power minus st by 2 square. So this is of the form a square minus b square. So we can write this as a plus b into a minus b. So this is e to the power 1 plus e to the power minus st by 2 into 1 minus e to the power minus st by 2. Let us write this a into 2 pi by t by s square plus 2 pi by t square into 1 plus e to the power minus st by 2 by 1 plus e to the power minus st by 2 into 1 minus e to the power minus st by 2. So in the numerator and denominator these two will get cancelled. So Laplace transform of this function is equal to a into 2 pi by t by s square plus a into 2 pi by t by s square plus 2 pi by t plus 2 pi by t square into 1 by 1 minus e to the power minus st by 2. Okay, this is the Laplace transform of this function. Now let us conclude for today. I will require 1 or 2 more lectures to complete this topic of Laplace transform. Thank you.